All right, video 2 here. So that was when we add or subtract something to our linear functions. Now what happens if we multiply or divide by something? In this case, multiply. All right, here we go. So stretches and compressions. A, how does multiplying the output of a linear function affect its graph? So now we're going to take our function and we're going to multiply the output by something. And again, remember the output is the y. Okay. So notice here, we're going to compare these two graphs. F of x equals x plus 1 and g of x equals 4 times x plus 1. So notice that 4 is on the outside. It's not directly next to the x, it's outside of the parentheses. So this affects the y. It affects what happens after you add 1 to the x. All right, so this is what we're focused on. So over here, this graph is f of x, the blue one. Right, it says right here, blue. Okay. So then this is a k for that multiplier, and in this case k is 4 right now. So this is our g of x. So you can see that what has happened is that this red line has gotten steeper. Right? The blue line is here. When we put this 4 in front of it, the slope got steeper. That is exactly what happens when you multiply your linear functions by a number greater than 1. If you multiply something greater than 1, and it's right here, greater than 1, the transform graph is a vertical stretch. So greater than 1, it's a stretch. Oh, vertical stretch. If the number in front is between 0 and 1, so typically like a fraction, like a 0.25 or a 0.33, then it's a vertical compression. So this is just a very, 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 very important idea here. Okay. So if we take a look at a point, let's compare, right? So let's go to f of x. Let's compare this point right here. So this is the point 0, 1, right? Because of that 4, what it does is it takes that y coordinate of 1 and multiplies it by 4. So if you take 4 times 1, you get 4. Notice here, that is the point 0, 4. That is exactly what happened with this 1 value. You times it by 4 and you got 4. So the y's are 4 times as great. Now I'm going to go on to Savas here, and we're going to explore this a little bit so you can see some immediate change. Okay, so now I can change that slider. So let's change it. So again, if we go all the way up to 5, notice that it gets even more steep, and that point is 0, 5. Now what if I go lower, right? As I'm approaching 1, notice I'm getting less steep. If I get to 1, notice I'm the exact same line because I'm not multiplying by anything. And now look what happens when I get less than 1. My line is becoming flatter, right? The red line is flatter. That's called a vertical compression. Okay? So keep in mind that that number being multiplied out in front is going to vertically stretch the graph. Cool. That's really neat to see that in real time. All right. Let's see what comes next. Okay, so now, second part of this, how does multiplying the input of a linear function affect its graph? So now, we're going to multiply the input. We're going to multiply the x. So again, notice here, in this equation, f of x equals x plus 1, and now we're going to do g of x equals 3x plus 1. So notice the 3 is inside with the x. So that's the first thing we do to the x. We multiply by 3. All right, so again, in this graph, here's your f of x, the blue graph, x plus 1. Your g of x has that k inside of it. The k is 3. So it's going to go right inside. So this is g of x. So now let's see what happens, right? So now we're thinking horizontally, right, because we're affecting the x. If I look at a point here, let's look at this point right here. This is the point 3, 4, right? How does that point compare to a point on its same level? Well, let's compare it to this point, right? So this point has the coordinates of 1, 4. So just like with translations, the x worked backwards, same thing happens in stretches and compressions. So in this case, instead of multiplying the x by 3, you're going to take the x and you're going to divide it by 3. So if you take 3 and divide it by that k value 3, that's going to get you that 1. That's how we got the x value of 1 there. So this time, if your k is bigger than 1, you are going to do a horizontal compression. You're going to get closer to the y-axis. So notice that this blue got closer to the y-axis. And if your k value in with the x is between 0 and 1, if it's a fraction of some sort, right, like a 1/2, you're actually going to horizontally stretch it. It's actually going to get wider. So it has like a backwards effect compared to the vertical. So let's go ahead and take a look at this. Okay, so let me get to part B. Here we go. Okay, so again, now we have this graph of x plus 1. We have this kx plus 1. So k is 3, right? So notice how horizontally your graph is getting closer to the y-axis. If I keep going to 5, it's going to keep shifting left horizontally. You'll see. So closer and closer to the y-axis. Now, if I let my k value get smaller, closer to 1, notice how it's getting away. It's horizontally stretching away from the y-axis. If it's 1, it's exactly the same. And then if you go less than 1, notice how it's flattening so far out. So this point right here is getting so much further away from the y-axis. So that's a horizontal stretch if it's less than 1. All right, so again, there's a lot of, I don't want to call them rules, but guidelines, patterns to follow with these transformations. So do your best. You can always use XY tables to kind of graph the things, but it's good to be able to look at a picture and try to guess or have an idea of what's going to happen to the graph. Right? Very, very much a predictive skill in math. All right, so thanks for watching video 2. Good luck on your practice.